Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today we're wrapping up part 2 on a 2-part series where we review some data handling user-defined function blocks that we've just released and posted on our website. Now, last week we went through some data sorting UDFBs. Here's specifically today's topic: array math in the Horner OCS. Now, because of my travel schedule, I did pre-record today's video, but rest assured we have folks standing by as we stream live the pre-recorded video. And if you have questions and comments, we'd love to see those in the chat section. If you're watching this on replay like a lot of you do, give us those comments in the comment section and we'll get back to those just as soon as we can. Now, because I did pre-record on a Saturday, hopefully Casey is spending some time with his family today, so it's just me. Let's take a look at how we break down today's topic. Okay, we'll start out by talking about what is array math and what is it useful for. We'll do a step-by-step introduction to each of the new array math user-defined function blocks that we're introducing today. We'll do at the very end just a quick review of the recent UDFBs that we've added over the past month or so, and all throughout there'll be plenty of demonstration. Let's get started. Okay, so what is array math? Well, that's when we want to perform math operations on a set of machine data, not just a single data point, but a whole set of machine data. And the way we access that machine data is through a variable array. So a variable array of temperatures or pressures or whatever the case may be. Now, the types of math operations we may want to perform on that data set include addition, averaging, finding the minimum, finding the maximum, finding the standard deviation, and more. And we're going to go through all of those today. Now, the function blocks I review with you specifically today are going to be integer-based. In other words, they're working on a data set where the variable array is integers. Now, rest assured, we will release floating point and double integer versions of all those UDFBs. But for now, the ones that are available as we record this video, as we present this live stream, are the integer versions. So what is array math used for? Well, sometimes you need to do math on a data set as an integral part of machine control operation. Okay, let me give you a couple of examples. So one example might be where you have a series of products that you've produced, and every time you've produced the product or a particular product, you have captured the weight of that product, and you've got an array of those product weights that are all being loaded into the same trailer, let's say, the same semi-trailer, and you want to do array math so you can calculate the weight of that trailer to help you determine when it's time for that trailer to be full and to be picked up, for instance. So that's one example. Another example might be in an agriculture application where you're weighing animals in a livestock application, and you need to take a look at what the maximum animal weight was in the data set or the minimum animal weight in the data set in helping you effectively deal with different animal weights as part of the integral machine control. So there's a couple of examples where it's just integral to the control. Now, sometimes you need to do these sort of math operations just strictly for statistical purposes, and maybe you want those statistical calculations to be done by the OCS itself. So one example might be for finding the average temperature in a batch of products that were just produced. Okay, so you've got an array of temperature values from your recently produced products, and you want to find the average. Another example might be finding standard deviation. Again, maybe you've got a series of products and you've captured some key process parameters and you want to calculate on that set of products and that set of process parameters what your standard deviation was to see how closely you're following your targets for your processes, for instance. So there's some different examples of where you might use array math in different applications. So now let's dive into these array math user-defined function blocks. Now keep in mind, Cscape has an extensive list of mathematical functions, whether they're arithmetic, logarithmic, trigonometric. that are built into the Cscape instruction set. Now, array math is not built into the instruction set, and that's why we've created these user-defined function blocks that you can import into your project and easily perform these array math operations. So now we're going to go through these one by one. All right, the first one we're going to cover is a UDFB that allows you to find the median value of an array of variables, integer-based variables. So what is the median? Well, that's effectively the middle value in a data list which has been sorted either in ascending or descending order. So if you remember last week, we reviewed with you some UDFBs that can perform sorting of a data set in either ascending or descending order. And those are available for integers or floating point or double integers. Now, we're using some of that inherent code that we developed for those sorting UDFBs. We're using that inherent code in the median UDFB. Now, because there is sorting involved, the first step in the performance of the UDFB is it has to sort all the data in ascending order in your data set. Because that can be time consuming and can impact your scan rate, we have limited the size of the input array to 100 elements for this particular function block. The rest of the function blocks I'm going to talk about today have a limit of 1,000 elements in the function block. So let's take a look at the inputs and the outputs for this median function block. So on the input side, we have an enable bit, which is going to enable the function to perform. We have a integer array, what is the data that we're actually going to be finding the median of. And then we have a length input, which is a unsigned integer that tells us how long that array is. And again, in the case of this function block, it's anywhere from 1 to 100 elements. 100 is the maximum. With the other function blocks we'll talk about later today, those can go up to 1,000. On the output side, you've got a done bit. You've also got an error bit in case that you get the length wrong. If you forget to set the length and it's set to 0 or you've set it greater than 100, you'll get an error. And then your median output is actually reported as a real value. Now, why are we reporting it as a real value? Well, when you find the median of a set of values, if that data set is an odd length, then the exact middle element in the sorted array is going to be your median. So that would be a round integer value if your inputs are all integers, but only if you have an odd length array. Now, if you have an even length array, then it's the two that are in the middle that need to be averaged to come up with a median. And then you're going to potentially not end up with an integer-based result. So that's why we've got a real result in terms of the format of the median for the output of this function block. Okay, now let's take a quick look at the flowchart for what's happening inside the UDFB. And we're not going to go through every single detail, but you can freeze this frame upon reviewing this particular video to get all the details if you wish. But basically, we're going to start after the function block is enabled by doing an error check. We're going to copy the input array to an internal array so that we can sort it and not touch the original array. After we've sorted it, then we're going to detect whether it's an odd or even data set based on the length parameter that was presented. And of course, if it's odd, we're just going to find the middle element in the sorted array. If it's even, we're going to average the two in the middle as the result. And the result we reported as a real value. Okay, so that's the median operation. Let's head to Cscape now and take a look at that function block. And here it is, already been imported and in use. All right, now I'm not going to go through today the logic that's inside this function block. All right, now when we post these on our website, we're going to post them so you do have the ability to double click after you've imported them into your project. You do have the ability to go in and take a look at the well-documented logic inside of these UDFBs, but you really don't have to in order to use them. In order to use them, all you really need to do is just connect the inputs and the outputs appropriately, and you'll be good to go. And all of these function blocks, as most of our UDFBs are, were designed to be always on. In other words, the enable input will determine whether they're operating at any given time, but they should always have power to operate as expected. Now, one thing I'm also going to show you quickly is how do you actually import a UDFB for use in your project. So I'm going to get out of debug mode here, and I'm going to click here on logic modules, and I'm going to right click and say import logic module. Next, I would navigate to the folder that contains the UDFBs I'm interested in. Then after I've navigated to that folder, I will make sure that I do star.cpu so I can find any of the UDFBs in that folder that I want to import. Now, I've already imported all of these, so I'm not going to do it again. All right, it's not needed, but that's how you would do it. You would select the file and hit open, and it would be added to the bottom of your list of UDFBs. And then for all the UDFBs, after they show up on your list, you can access them from over here in this part of the toolbox. All right, so that's all the Cscape work I want to show you for this week. All the function blocks I'm going to show you are imported the same way. They all connect to the always-on contact the same way, and they have similar inputs and outputs, which I will review in detail on the slides. All right, let's head to the bench, however, and take a look at this median function block in action. I've got an example here where I'm showing some different sets of data. So here's my first data set that I've already loaded. Let's go ahead and find the median of that set. Now, this set has not been sorted before it was executed, right? So our result on median is 68. Now, we've got an even length list with an index from 0 to 9. So the first thing that this function block did was sort the data in order, and then it took the two middle values and averaged those together to come up with a median. And the result in this case was 68. Let's take a look at some other data sets. I'm going to load another data set. Now this one happens to be pre-sorted, so it was already sorted before this median function block was executed. And I'm going to execute it now, and we can see very simply that the median is the average of the two middle values, again, because this is a even array list. So the average of 57 and 98 is 77.5. I'll take a look at a third data set here, okay, which is also sorted, okay, and again, we took the average of the middle two values, which turns out to be 92, 84.5. And notice that these are all integers on the input side, and my result is a real or floating point value. So that is the median UDFB in action. All right, let's head back to our material and take a look at our next function block. The next two that we're going to look at, the first of which is the sum function block. So this function block is pretty self-explanatory. It goes through an entire list of up to 1,000 elements in an array and sums them all together. The inputs are very similar to what we just reviewed with median. We've got an enable bit and a length parameter, and then the integer-based array, which we are going to be using to execute the sum up function. Now, on the output side, we have the done and the error bit, and then we have our sum. Now, the sum is actually being reported as a double integer, okay? And that should be fairly obvious. If you're summing up a whole series of integers, you could overflow an integer length. So having an output that's in double integer format just makes sense. Let's take a quick look at the flowchart for the sum. Pretty straightforward. We're going to calculate what our final index is going to be as we're working our way through the array. We're going to start with an index of 0. We're going to use an indirect move to pull the first value out of the array and add it to a running sum, which is going to be in double integer format. We're going to increment, we're going to check and make sure that our index has not reached maximum yet. If it hasn't, we're going to increment the index, grab the next value, add it to the sum, and do it over and over again until we've reached the last element in the array. And then once we've reached the last element, we're done. We report the sum, and again, we're done. Another similar UDFB to sum in terms of operation is average. And this one is fairly obvious in terms of where you might use it, right? There's plenty of times where we've got a set of data and we want to find the average of that set of data. And that's really what happens here. And to find average, what do? Well, you sum up the values and you divide by the number of the values in the list. Aha. So that utilizes all the same logic that we just talked about in the sum UDFB and adds a little bit to it at the end. You can see the inputs are again integer-based array, and this time the output is expressed as a floating point value or a real value. Now, looking at the logic, it's nearly identical to what we just reviewed with sum, except we've got the step at the end where we do the dividing of the sum by the number of elements in the array to calculate our average. And of course, the result is real and not double integer. So that is sum and average. Let's go ahead and head to the bench and take a look at that in action. So we've actually got two function blocks being executed by the same start button here. We've got a sum function block, which will be reported here, and a average function block, which will be reported on this side. All right, so let's load up that first data set, and let's find the sum and the average. So if we took the time with our calculators, we could verify that. One nice thing about having a data set of 10 values, if you've got the sum, obviously finding the average is easy to verify that the average is 1/10 of the sum, for instance, okay? Now let's take a look at our next data set that includes some big negative values in there. There's our sum and our average. Let's load up the third data set and again find the sum and the average. So you can see how that operates. Again, when I press the start button, I'm actually executing two UDFBs. I'm executing a sum UDFB and an average UDFB. That's just the way I've written my particular example here. Let's head back and take a look at the next UDFB. And this is actually a pair of UDFBs that we like to think about together, and that is min and max. So these are pretty obvious as well. With these function blocks, you're going to use those to search through an array of up to 1,000 integers and to find the minimum, in the case of min, or the maximum, in the case of max, values in the list. Now, in addition to reporting the min and max value, min or max value, depending on the UDFB, it also reports one other thing, and that is it reports the index value where the min was found and the index value where the max was found. Why is this useful? Oh, and one other important point. It's the index value where the first minimum was found or the first maximum was found. So let me give you an example. Let's say we have 100 values in a list, and effectively we're looking for the minimum value, and we use the min function block, and the min happens to be 5, and we have 7 different occurrences of 5 in the list. Well, the first location of a 5 is the one that will have its index reported. So that's how that works. Now, where can this index value be useful? Well, it can be useful when, let's say, you are taking samples, let's say, of a temperature, a pressure, and a weight in your application, and you're taking them all simultaneously, and then you build up a set of data, and the index for each of the 3 lists is synchronized. So index 5 indicates the 6th sample you took for temperature, pressure, and weight in the 3 different data sets that you've got. Well, if you're looking for the minimum temperature value sample and you use the min function block to find that, and it reports back an index of 12, you can then relate the pressure and the weight for that same sample with the one that had the minimum temperature. So that's one of the reasons why we also report the index value of where that lowest or highest value was found. Now, taking a look at the flowchart for this operation, again, pretty straightforward. We're going to go through, depending on if it's min or max, and just search and compare each value in the list to see if it's below the currently maintained minimum or the currently maintained maximum. When we get all the way through the list of values, then we're done and we report the result. Along with, of course, the index that we stored away when we stored away the first of the minimum or maximum values. Let's head back to the bench, and now let's transition over here to our min and max page. Let's load our first data set. And again, this data set is not sorted, so when we hit start, it's not going to sort it for us, but it's going to tell us what the minimum value is and the maximum value is. So it's telling us the min value in that list is a 1. There it is, a 1. We can tell from quickly scanning the list that is true. The index for the 1, the first instance of 1, is an index of 2, which that's also true. Our max is 998, which is right here, and that's an index of 4. So that's how that works. So let's go ahead and load our next data set. And now this data set is already sorted. So since it's sorted, obviously the min is going to be the first on the list and the max is going to be the last on the list. But let's just go ahead and execute it anyway, so we can kind of verify that. All right, then let's load our third data set and see the results there as well. So that's our min and max function blocks, UDFBs. Let's head back and cover our final UDFB, which is standard deviation. Now, standard deviation is more complicated than any of the ones we've talked about before. So standard deviation is something that's extremely useful for statistical analysis, and it's used in quality control all over the place. So how do you calculate standard deviation if you're going to do it manually? Well, here's what you do. The first thing you're going to do is you're going to take your set of values and you're going to calculate the mean, which is basically just another word for average. So after you've found the average, then you need to examine each individual value in the data set and see how far its value is from the average and square that difference. And then you add all those squared values together. And then when you're done with that summing and squaring process, then you're going to divide by the number of data points. Now, let me go ahead and be clear here. There's two different variations on standard deviation. There's standard deviation for a population, where you really are looking at every element in the population. And then you have the standard deviation for a sample, which is what we typically use in industry. So that is where we have a list of samples and we're going to take the standard deviation of the sample. Now, when you're taking the standard deviation of a sample, you're actually dividing by the number of data points minus 1. And then you take the square root, as opposed to a population calculation, which divides by the number of data points. So there's a difference there. But keep in mind, this calculation, this UDFB, uses the sample algorithm. Now, after you've divided by the number of data points, minus 1 in our case, you take the square root of that value, and that is your standard deviation. Now, in the case of the standard deviation UDFB, you also have two outputs. You've got not only the standard deviation result as a real value, even though the inputs are all integer values in the array, of course, but we also report, because of convenience, the average value for that list as well. So with standard deviation, with that UDFB, you get both average and standard deviation as outputs. Now let's take a look at the flowchart. Now this one's a little more complicated, as you can see, and we've got a green box, which kind of represents the fact that when we find the average, we actually are kind of doing a flowchart within a flowchart there, okay? So finding the average, we basically use the same technique I reviewed with you on the average flowchart. So there you can see your way through the same process I described of looking at each sample versus the mean, effectively squaring the difference and summing those up, dividing by length minus 1, or the number of elements in the array minus 1, and then taking the square root of that and reporting that as your standard deviation. Okay, so that is the calculation for the standard deviation. Let's take a look at it on the bench. Let's load in our first data set and run the standard deviation. And you can see we report the average is 292, and there's our standard deviation of 398.42. Now, I went through and I validated each of these calculations in Excel with all of these data sets to ensure their accuracy. So you'll just have to trust me on this, that these are accurate. At least they match 100% what Excel calculated by doing the standard deviation function in Microsoft Excel. Okay, so that was the first data point. Let's take a look at the next data set, if you will. Find the standard deviation and the average as a result there. Okay, and then let's do the same for the third data set, and you can see we have our results there. Okay, so that's the standard deviation function block, UDFB, in action. So that wraps up effectively the new UDFBs that we are presenting today. All right, now I just wanted to share real quickly before we sum up, I want to share real quickly all the different UDFBs that we've released in the last month. So we started off with data-find UDFBs. that allow you to go through a list of variables, or effectively a variable array, and to find a specific value. So whether that's an integer value or a floating point value or a byte for a string, for instance. And let's say if you're looking for a specific value in that list, you can use the data find UDFB to accomplish that. And it'll tell you where in the list it found it, the first instance of it. We also last week released some data sort UDFBs that allow you to take a list of up to 100 long, or at least a variable array of a dimension of up to 100, and allow you to sort those data values in either ascending or descending order. And last week we showed you the integer versions of those UDFBs, but now posted we have not only the integer version, but we also have floating point and double integer versions as well for both ascending and descending order. And then today, of course, we have reviewed for you these array math UDFBs. We showed you the integer versions. Within 2 weeks of this original viewing, we will have also the floating point and double integer versions available. So if you're watching this on a replay a few weeks after the fact, they're probably already up there and waiting for you. Let's wrap up today's session. We found lots of applications for array math, whether as an integral part of the machine control algorithm or part of statistical analysis that you want to have the OCS perform as part of its duties to measure production performance or machine performance or whatever the case may be. And even though these array math functions aren't built into Cscape inherently, by adding these UDFBs to your project, it's very easy to perform these functions. This is the point in the process where I remind you we're here every Tuesday at 2 o'clock, whether we are fully live like we are most weeks, whether we're pre-recorded like I did this week. But in any case, as we stream our videos on Tuesday, we have people standing by to answer your questions. And if you're watching on replay, we'd love to see your comments in the comment section. A reminder, we're celebrating our 10th year of Horner Lighting Group products. We have lots of great Horner lighting videos available alongside our great automation content. We're getting into trade show season. And the first national trade show that we're going to participate in is Automate in Detroit, Michigan, May 22nd through the 25th. So if you're in Michigan or you're planning on going to Automate, we'd love to see you in our booth number 2044. We always have great stuff at the trade show, and it's a lot of fun to meet our customers and our prospects if you're not using Horner yet. We are finally releasing the firmware and the Cscape service pack that marries the micro OCS with OCS.io. Up until now, I believe you're limited to either the Prime series or the XL series when you are using OCS.io, but the micro series now supports OCS.io as well. And if it's not posted as of the day we're shooting this particular video, it will be posted within a day or two of the original airing. If you have not done so already, we'd love for you to subscribe to our channel. It doesn't cost a thing, and if you choose notifications when you subscribe, you'll be notified every time we go live, every time we post a new video. And we post at least one new video a week, this live stream, and usually it's multiple videos per week. Okay, so until we meet again next week, let's all get out there and do us some good.